Example 2. If a plane sets out on the bearing of east 27 degrees south for 1,000 miles, what x and y coordinate would describe its location? Okay, so now we're going to say, let's convert between a directional bearing and an x and y coordinate. So again, I'm going to draw this up and label it north, east, south, and west. And so we have a plane that takes off, and it's traveling east, so 27 degrees to the south. So something like this, where our angle here is 27 degrees. And it does this for 1,000 miles. What we want to know is when this plane is at this location, what x and y coordinate represents its location. Now we can see that it's going to be a positive x and a negative y. Now the way we would do this using trigonometry is we would say, let's make a right triangle out of this, and you always connect your right triangle to the positive x-axis, or rather to the x-axis. This one is the positive x, but it doesn't have to be. And this distance of the triangle would be our x, this would be our y, and we can see that h is 1,000. So if I wanted to find my y, I would use sine. If I wanted to find my x, I would use cosine, because I'm given the h. And we have psi y, cos x, and on both of those we have a silent h. So the way to set this up is I would say sine of 27 degrees will equal my y value over my h, which happens to be 1,000. The same is going to be true for cosine, but this will find the x. Now, how would I solve both of these to get the x and the y by themselves? I would multiply by 1,000. Okay, I want to multiply by 1,000. Now, what that'll do is I'll remove the 1,000 from the right side, and this will show me what I need to type in the calculator. Now, remember, we're going to change the y to negative since it's going down. So I'll come over here, I'll go to menu, I'm going to choose my calculator, and we'll say 1,000. And then we go to sine of 27 degrees. And though my calculator is in degree mode up there, I always am safe. I just type in, I press the pi button, hit degrees like that. I'll press enter. That gives me my y, except we'll need to change that negative. And now I'm going to do this again, and I'm going to change this to cosine. And so if you don't know this, you can just delete the sin and replace it with cos, just like that. 891. This means that this point right here is going to be, I'll write the y over here. Y is going to equal negative 453.9. I'm just going to round this to negative 454. And this x, I'm going to round and have this be 891. Now we're saying it's negative because it's going down. So the way we write this as a coordinate point is x would come first, 891, comma, negative 454. Close my parentheses. This is my answer here. Let's look at part B. If the plane sets out on a bearing of 117 degrees and travel on the bearing for 2 hours and 2 hours at 450 miles, what x and y coordinate would describe the airplane's location? Now this one, it says bearing, which technically would mean we go from the north, but here what I want to do is I want to use how it would be given mathematically. Here's for pre-calculus and DISD anyways. If we see this, what we're going to do is 100, I'm just going to erase this word here. It sets out and it's traveling 117 degrees. What that would mean is we're going to go from the positive x-axis 117 degrees. And so let me draw a little line here. That's 90 degrees, and so 117 is 27 past it. So it's going to be something like this. And it says 2 hours at 450 miles per hour. So right there, whoops. This is going to be 117 degrees, and 2 hours at 450 miles per hour. So 2 hours times 450 miles per hour. And if you're not sure, miles per hour means we're dividing by hours. And this over here is hour, like that. So the hours would cancel each other out. And so 2 times 450 means we travel 900 miles. And so that's what I'm going to put over here is 900 miles. And I'm going to move it on this side because, again, what we do to solve this is we always connect the line to the x-axis to create our triangle. This is our right angle. This is our y. This is our x. And we want to find this point, and we'll represent that point as x, comma, y. So again, they gave me VH. So I'll do the same steps again. I will say that sine of 117 degrees will equal my y value over 900, and then cosine of 117 degrees will equal my x value over 900. And I'm going to pause right here just for a second. What could solve this previous one correctly is once we realized the angle was down 27 degrees, we could have typed in the calculator negative 27. If we would have done that, we would have got the right answer from the start. If I wish would have put this as negative 27. Since that angle was going down, that would have changed all the math and it would have given us the right answer. So that's just a little shortcut that I didn't think of earlier, but now as I'm at 117 degrees, this will know that it should be a positive y, and it's going to give me a negative x. So when I type this in, this time we'll have a better answer. So I'm going to come over here again. Let's do the one step. I need to multiply by 900 on both of these. So when I multiply by 900, I have that 900 right there. Those will cancel out. Those will cancel out. So we'll have 900 sine of 117 degrees. And this should give me a positive answer. It does. And then I'll do this again, except I'm going to change the sine to a cos. When I press enter, notice it gives me the negative because mathematically it knows where 117 degrees is. So our answers this time would be that y equals, I'll make it 802. I'll round to the nearest mile. And here, this will be x is equal to negative 40. This would round to 409. And so that would be my answer here. Let me just put it over this way. Negative 409, comma, 802. And that's to the nearest mile is the rounding there. Now, I have one for you to try. See what you come up with.